All right, here it is, an example of kind of a perfect storm problem involving exponents. We've got a lot of stuff going on here. We have a big fraction with a bunch of powers in it being raised to a power itself and then multiplied by another quantity that has several different powers going on inside of it. So this really has a lot of moving parts when you first look at it. According to the title at the top of the page, we're going to end up having to use all three of our different rules, the power, the product, and the quotient rules. And also we've got some negative exponents floating in here. So this really does have something for everybody. Let's see if we can develop a strategy to solve this problem as thoroughly and patiently as possible. So the first part of the strategy to me involves the order of operations, PEMDAS. The second part is definitely have patience. Try and write out all of your steps, because if you write them out, you're much less likely to make a mistake with them. And then there's the exponent rules themselves, which I conceptualize in this arithmetic layer cake. If we're doing any multiplication or division of powers, we can instead add or subtract the exponents to simplify. Likewise, if we do any exponentiation of a power, then we can instead multiply exponents to get ourselves through that. So let's start by thinking of the order of operations as we go along, which begins with looking at parentheses, then exponents, multiplication and division, and then addition and subtraction are saved to last. We don't have any addition or subtraction here, so probably it's just those first four things we need to worry about. So let's start with parentheses. I'm going to kind of recopy the problem here just so we have a second copy of it to look at and annotate. First of all, I want to make all the operations in this expression visible. I want to make sure that we don't miss any multiplication happening somewhere, miss any division happening somewhere, and so on. So I'm going to take all the parentheses and kind of highlight them. There's all the parentheses in this problem. We're going to ask what function they serve in just a moment. Here's all of the exponents going on, including that hidden 1, which was on the plain old u. Up in the numerator of the fraction that's in the first set of parentheses. Here's all the multiplication going on in that problem. Again, don't forget that multiplication by the coefficient 2 in front of the x to the minus 3. That is a separate operation going on. The order of operations says that that power applies only to the x. The power negative 3 doesn't apply to the 2 because of that multiplication sign that's hidden in between. And finally, what about the division? There's one division operation. It's right there, the fraction bar. So now we can see where all the operations are happening inside of this problem. And the order of operations tells us that we can start, or should start, by looking at those quantities which are inside sets of parentheses. And there are two sets of parentheses here. Let's talk about each one, starting with the one on the right. My question is, what function is that set of parentheses serving? And the answer is none. It's grouping together the x squared and the z to the minus 1. But then outside the parentheses, all that's happening is, again, multiplication. Right? They're multiplying that quantity by another quantity in front of it. It's not being raised to any power. It's not being divided by something else on the outside. All that's happening is multiplication. And luckily for us, that means that those parentheses on the right are serving no valid purpose whatsoever. The associative property of multiplication tells us that we can just feel free to ignore them. We can totally get rid of that set of parentheses that's there on the right. So one less set of parentheses to worry about, because it doesn't matter if we put them there or if we don't put them there. So it's more convenient to leave them out. The first set of parentheses, on the other hand, is serving a purpose. Let's look at it for a moment. This set of parentheses is really important because it's grouping together a bunch of factors on the inside. And that combination of factors, once we've evaluated it completely, is being raised to a power. Namely, it's getting raised to the power 3. Right? So those parentheses are important because they're grouping together the base of the power whose exponent is 3. In this example. And if they weren't there to perform that grouping, the order of operations would apply that 3 only to the next most nearby thing to it. Right? So those parentheses are always ways of subverting the order of operations, to say all this multiplication and division inside the parentheses has to happen first before the power of 3 is applied to the whole thing. So those parentheses are important, which means we have to do something to get rid of them. That's going to be our first step. And so here we ask ourselves, is there a way to move that exponent from outside of the parentheses to the inside? Specifically, can that exponent be distributed over the operations that are inside the parentheses? And the answer to that question depends on what the operations inside the parentheses are. If the operations inside the parentheses consist only of multiplication and division, then fortunately for us, the answer is yes, because that is the case here. If there were addition or subtraction going on inside those parentheses, we would be stuck. There would be no way for us to distribute the exponent across addition or subtraction. So we can and should distribute the power 3 to each of the factors that are inside that big set of parentheses. We can do it, again, only because the parentheses contain only the operations of multiplication and division on the inside, and there is no addition or subtraction. So let's distribute. That power of 3 has to be distributed to 4 different factors. It has to be distributed to the 2, it has to be distributed to the x to the negative 3, it has to be distributed to the u to the power 1, and it has to be distributed to the z to the power negative 2. That's down in the denominator. So now that power of 3 has been applied to each of the factors that's inside the big pink set of parentheses. That helps because now the remaining parentheses only have the function of telling us that we're going to raise some powers to powers. That's something that we know how to do based on our previous example. So let's do it. Let's tackle all the exponents that we can tackle now that we've finished with all the parentheses that actually serve a grouping purpose. So we can simplify a power of a power, an exponential of a power, if you like, by multiplying the exponents together. That's, again, the arithmetic layer cake tells us we can do that. So where we used to have x to the power negative 3 to the power 3, we can multiply the negative 3 and the 3 and get x to the power negative 9. Where we used to have u to the 1 to the power 3, we can instead have u to the 1 times 3, or u to the third. And where we used to have z to the negative 2 to the 3, we now have z to the negative 2 times 3, or z to the minus 6. Also, that 2 to the power 3 that we have out in front of the whole thing, the coefficient, which we raised to the third power, we can simplify just by writing 2 times 2 times 2, which is 8. So now all our exponentiation is done. And we now have just kind of a list of a bunch of factors. Well, let's talk about multiplying those factors together. We can simplify a product, in other words, a multiplication of one power by another power, by instead adding the exponents together. Again, same trick that we learned a couple of videos ago. But in order to do that, we should probably rearrange these factors first to put the like factors together. Put the powers of x near one another, put the powers of z near one another, and put the powers of u near one another. So we'll have a space here for the numbers, we'll have a space for the powers of u, a space for the powers of x, and a space for the powers of z. Well, there's only a single numerical coefficient here, that's 8. There's only a single power of u here, that's u to the power 3. But there is actually 2 powers of x being multiplied, x to the negative 9 and x to the 2. And there's 2 powers of z being multiplied, actually in this case divided, z to the negative 1 and z to the negative 6. I'm going to reinstitute the multiplication signs in front of all those things that are being multiplied, but then also a division sign in front of that z to the minus 6. After all, that z to the minus 6 is in a denominator, and since it's in a denominator, that means we're dividing by it, not multiplying by it. That's going to be really important in just a moment. So now what we can see is that what we have left to do is a bunch of multiplication, all the yellow dots, and then also one step of division, that green division sign that's there at the end. So let's do it. If I elevate that multiplication of those 2 powers of x into an operation on their exponents, it becomes addition. So instead of multiplying those 2 powers of x, I can add their exponents, negative 9 plus 2. The z's, on the other hand, because we're dividing their powers, if we elevate that operation into their exponents, it becomes subtraction instead. So instead of dividing those powers of z, I'm going to subtract the exponents, negative 1 minus negative 6. Talk about a sign error waiting to happen. So we'll try to avoid the sign errors and do out the arithmetic. Negative 9 plus 2 gives me negative 7 for the power of x. And negative 1 minus negative 6 is the same as negative 1 plus positive 6, which gives me positive 5 for the power of z. And now we've handled all the multiplication and division that is fit to handle in this problem. We've completely simplified all the products and quotients of like factors, powers that have the same base. So what we have left is something which cannot really be simplified any further because we have an 8 by itself, we have a power of u, u to the third, we have a single power of x to the power minus 7, and we have a single power of z, z to the fifth. So the only thing that's left for us to do is to trade that negative exponent on my x for a positive 1 instead. The same way we always do, by instead trading multiplication for division. So instead of a negative 7 in the exponent, in order to make that positive, I'm going to make the operation in front of that power a division instead of multiplication. And writing that with a fraction bar, I get my final answer having 8 u to the third and z to the fifth in the numerator, and x to the seventh in the denominator. So that was a lot to talk through. But where I do see people make mistakes in problems like this, it's because you try to take too many steps at once, if anything, right? That oftentimes students will fail to write down their intermediate steps to make sure that they can see on paper what's happening in their brain. And as a professor, that's also what I grade on when I ask you to show your work, is I want to know what's going on in your thought process. And if you don't know what's going on up there, then I'm certainly not going to either when I grade your work. So making as many of those intermediate steps visible as possible is really the way to avoid making any mistakes and taking too many steps at once. So what did we do? We first looked at all the parentheses that were in this expression and asked what purpose they were serving. In one case, the parentheses on the right, they were serving no purpose whatsoever because it was just a string of multiplication and no powers and nothing else fancy. So we just got rid of those. But the first set of parentheses was serving a purpose. It was grouping together a bunch of factors, which are all being raised to the third power. And that told us, again, because there's only multiplication and division inside the parentheses, that we could distribute the power 3 to each of those factors on the inside. When we did that, we realized that our next step was going to be to simplify 2 to the third, x to the negative 3 to the third, u to the first to the third, and z to the negative 2 to the third. And that required us not only to compute 2 to the third is equal to 8, but more importantly, to know that taking a power of a power is the same as multiplying by exponents. And so we ended up with a total of negative 9 powers of x, 3 powers of u, and negative 6 powers of z from what used to be that big quantity in the parentheses. Now that parentheses were gone, we were free to finish multiplying and dividing. We did that by rearranging all the factors to get the like factors, the powers of the same base, next to one another. So there was an 8 and there was a u to the power 3, which are not like to one another, but there were 2 different powers of x and 2 different powers of z. In the case of the powers of x, they were being multiplied. In the case of the powers of z, they were actually being divided, right? Z to the minus 1 divided by z to the minus 6. And that gave us the clue that we needed to move that arithmetic up into the exponent instead. Instead of multiplying the powers of x, we added the exponents on the x, which gave us negative 7 powers of x in total. Instead of dividing the powers of z, we could instead subtract the exponents on those powers, giving us negative 1 minus negative 6, which is positive 5, total powers of z. Finally, all we had to do was rewrite that expression by swapping out negative exponents for positive, and doing so, trading out multiplication for division, which had the effect of moving that negative 7 powers of x, which were in the numerator, down to positive 7 powers of x in the denominator. This is a good example problem to rework yourself. Once you feel like you have a good handle on how all the individual properties of powers and exponents work, and if you can navigate this particular problem and problems like it, then that really means that the whole first half of Unit 2 is mastered for you. It's under your belt. If you have this working for you, then that really is fully half of what you're going to need to have mastered in this second unit.